One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. We see that we've seen the graphical illustration, the code explanation, the debugger tool explanation as well for this one. Now we are going to go into the complexity. What's the complexity saying? How does it balance with time? How does it balance with space? Is there room for improvement in the optimization? And basically all these questions we are going to be answering in a bit. Now for time, we say all nodes are visited at least once. So we see that again, that all nodes are visited. So for that reason, we say O of n, because the amount of n's is like the number of nodes we have. So we make use of n as node and say, okay, if n is node, then all nodes are visited at least once. So we have time complexity of n, right? And yeah, that's how we derive that again. And we could see that's same with what's it called, the first one, right? That's the recursive one, right? We still see have same O of n or time complexity. Now when we get to space is where it becomes interesting, because we use the stack. Now when we use the stack, one might say, oh, um what is it called, the stack is growing and dropping. But in an ideal situation, there will be a situation where, oh, let's say you only have one value in your tree, and your n is the value number of nodes, or basically you have a single node and n is the number of nodes. So far that goes into the stack, that's an n or O of n. So basically that's what's it called? That's O of n space. So yeah, forgive my write-ups here. These are for me, right? But yeah, that's how we derive O of n, because obviously we're talking about the worst case scenario, and where what space would be in relation to the amount of nodes, right? So we see that if for that instance we see that n would be the same and stuff like that. So yeah, we just go through it and we see how we visit every node for, let's say, an ABCD um tree. But yeah, we've already explained that. So basically that's it for complexity. For this guy, we still have an O of n and O of n as seen in recursion. So next up, we are going to be going into something called Morris transversal. Very, very interesting concept, and I believe as well that the graphical illustration will be the guide to bring it home before we then begin to see the solutions around it, like the debugger tool and the code explanation. But first off, as always, we start with the code explanation next. See you on that one. Muchas gracias. Bye.